that is another test. So what are the tests that we have so far? Do you remember what we had some tests where we did a particular experiment to test for something?
Pop test.
Pop test? So we were testing for what?
Hydrogen.
Hydrogen gas. What's another test?
Lime water test.
Lime water test, and we're testing for
Carbon dioxide.
carbon dioxide. There was one more test that was demonstrated for you.
Oh, is that the one?
Yes, the oxygen. So the oxygen relit the glowing split. Yep, so they are our three tests for gases. We have a test here as well, and we call this a test for saturation. Because our alkanes are saturated. Only contain single bonds. Alkenes and alkynes, we call them unsaturated. And that means we have double and triple bonds. You know, like you have polyunsaturated margarines or other kinds of fats, etc. The unsaturated there tells us that there are double or triple bonds present. And it's because we have double and triple bonds in the alkenes and alkynes that we can undergo addition reactions. Now our example is this one here. What's that called? What's this called? Yeah. Well, I'm just going to write the bromine, this bromine water that we often use. So we've got some bromine molecules in water. What happens is the bromine comes up to our unsaturated molecule. This bond here will break, form a new bond, and this bond here will break and form a new bond. So our product
Is it bromine water? What is that?
That's just what we use. It's
Just bromine.
it's bromine in water, but it's not here. Yeah. And this is brown. So this one here was colourless. And this one here is colourless. So, adding our bromine water that has this brown yellowy colour, we're going to have a very rapid reaction to form our product here that is going to mean that we lose that colour. So this is why the bromine water can be used as a test for saturation. Because we know that if I add the bromine water to an alkane, it's a very slow reaction and it needs a catalyst, and so it's not going to happen very rapidly. But if I'm unsaturated, if I've got double or triple bonds present, then the reaction will proceed very quickly and we'll know it's happened because the colour will go from the bromine. What am I going to call this? What's my product's name? Now, we talked about making lots of isomers of things with our substitution reactions for our alkanes, what would happen then? Is that going to be an issue with our alkenes? Firstly, what's this one's name? Yep. Okay, how about we react some pentuine with, this time again with bromine water. What's my product? What are my potential products? So I know I can write out my 5 carbons in a chain there, that's all staying the same. I can put these hydrogens on up the top here. The thing is, that if we look at remembering the mechanism for this bromination, there's actually only one product, and it always has to be that the halogen is added across the double bond. So this is our only product. Yeah, so what's the name of this one?
2,3-dibromo
Now, this reaction, it's the same if I had chlorine water, if I had iodine, it's all the same reaction. I can use any of my halogens and have the same reaction. But most of our reactions focus on using the bromine water because we can use it as a diagnostic tool with this colour change. Right? But the reactions would all be the same for the other halogens. Now we've only looked there at alkenes. I'm going to just do an alkyne for you as well. So let's do that. Again, get working on some questions. So what's this one called? Its name? Do I need a number in there? That's right. Yes, we don't need a number. Now, in actual fact, we'll do it this way to start with. So I've got my chlorines. It's the same mechanism where my chlorine's going to come across the triple bond this time, and I think that's right. Yep, yep. But that's not the end of the story, because if I add more chlorine, right, then what's going to happen then? It's the same thing. that my final product is this.
So you've made your final product, it's now saturated.
Yeah, it's saturated, it's gone, because if there's still more chlorine around, then we know that from our previous look at the alkenes, that this reaction would proceed quite rapidly. So what's this one's name?
One and two tetrachloro.
Would be 1,1.
2,2.
Tetrachloride. There.
That's right. Now, I could have, I guess, done this in one step. I could show you that this actually would work in one step if I did this. Right, I just need 2 chlorines and then that would be my product. Yeah, does that make sense? But all I was doing there was showing you that it occurs in 2 steps.
So basically, what you want to try and do is, as the end product, you want to try and have it as an alkane.
Yes, well, it's going to saturate. Yeah. So if alkanes have only single bonds, then this is a saturation reaction or an addition reaction. And we're going to add until we've added, we don't have any of those compounds present. Yeah, does that make sense? Okay. Good-o. So there's some questions you can go on with now in the booklet.